Chebyshev inequality. Let's start. So in previous lecture, we have seen that if we know the distributions of a random variable, then we can easily conclude some beautiful property of that random variable. But the question is, if we don't know what is the distributions of that particular random variable, then in such cases, what we are doing? So let's see that kind of problem that is solved by Chebyshev inequality. So let's see step by step. So let's take x is a random variable. X is a random variable, and in this random variable that have the finite mean, let's take this finite mean is mu as regular, and it's non-zero and also finite standard deviation, and non-zero and as well it's finite standard deviation. Thought I am writing STTDEP, standard deviations. Let's take its sigma. Okay, so our finite mean, that's the main thing that we have to remember. The mean is finite, and as well that's the standard deviations is sigma, and as well it is non-zero and also it is finite. That's the two things we have to remember. And suppose let's take we don't know anything about these distributions. We don't know anything. We don't know about its distribution. That's the structure of this thing. If we know the distributions of it, then as previous lectures, as previous theorems, we can easily conclude some beautiful properties of the distributions, and we can draw some we can take some conclusions of them. But suppose let's take we don't know anything of it, then what the thing? Just recap the previous thing we have. So in Gaussian, just suppose let's take, just I am discussing, just going to discuss the previous lecture that I have already known. Suppose let's take we know the distributions of these distributions. Suppose let's take these distributions are Gaussian distributions. Then what can, just I am recapping the things that we have previously learned. So suppose let's take this is the Gaussian distribution, that x follows the Gaussian distribution. Let's take its follow the Gaussian distributions. So in such cases, if we know its mean and standard deviations, and we know its standard and its distributions, then we can easily conclude the beautiful formula that already we have known: 68, 95, 99 rule. 99 rule. We can easily build this rule if we know these things. Then what rules are actually taken what rules are, suppose let's take the random variable x, it's follow the normal distributions with mean mu and standard deviation sigma, and we know these things. First that we have to know here, the things that first we have to know its mean, the second thing that we have to know its standard deviation, the third thing that we have to know its distributions. The three things that we have to. So let's take it, let's play with an examples, then I think it will be better for us. So suppose let's take with our x, the random variable, the taken random variable x is the distributions of the height of the student. It's the distributions, the height of the students. Let's take this, it's our distributions. So in such cases, suppose let's take here for this random variable x, the mean value for this random variable is, let's take this mean value is 150 centimeter. Let's Let's take its standard deviations is 10 centimeter, and let's take it's the normally distributed. Okay, it's normally distributed. That's I have taken. So then what are actually saying about the 68, 95, 99 rule? So the rule is actually telling us, the probability of mu minus 2 sigma, first mu minus sigma less than equals to x less than is equals to mu plus sigma, means I have taken a first standard deviation. It's about how much point? It's about 68% of the point that's contained in this range. Just to draw this. Suppose this is our random variable x, and it is its distribution function. It's a PDF function, and it's the mean value is this one. This is the mean value. This is the first standard deviation. Let's take it's the second standard deviation, and let's take it's the third standard deviation. Then the rule that the 6895 rule telling us that this range, suppose it's the sigma is lie on here. Suppose let's take the sigma is here. Then the first rule that this rule is just speaking about this point, these much points, this much point is about 68%. The second rule, 95% is 2 sigma less than is equals to x less than is equals to sigma plus 2 sigma. It's about 95% point acquired in this range, and that means in this range. I'm taking a different means in this range. It's total range in this range. In the whole range, this point is all about 95. Okay. In this range is a 95%, and in the third 99 means mu minus 3 sigma less than is equals to x less than is equals to mu plus 3 sigma. It's about 99%. Means it's telling us that this in this range, here to here, in this range, it's about 99%. This the thing actually telling the 68, 95, 99 rule that we have seen. These things are very important if we know the distributions, mainly if it is a Gaussian distributions, and we know its mean and standard deviations must be it is finite and non-zero. Then we can conclude this thing. Means non-zero means standard deviations is non-zero. Then we can. So suppose in these examples I have taken that our mean is 150 and standard deviations is 10 centimeter. Then we can easily from this rule, from this formula, then we can easily conclude that our in this range, 90% means in the range of mu means 150, in P minus 2 sigma means 20, 150 minus 20, 130, in the range of 130 centimeter to 170 centimeter. We have in this range, we have 95% students height. We have 95% students height in this range, 130 centimeter to 170 centimeter. We have this in this range 95%. Similarly, we can conclude these things. 95, this one. So I think you have understand this. If we know the distribution, but the question is in this lecture, the motto is just I'm recapping these things for our better understanding. Just up, but in this lecture, our main motto is if we don't know the distributions, then what? So the main questions in this lecture, the main motto is what if? What if I don't know? I don't know the distributions. What if this? If we don't know the distributions, then to enter, don't know the only we don't know the distribution, but we know. But here we know. Here we know the mean that must be finite, and as well we know the standard deviation that must be not equals to 0, and as well it is finite. We know these two things, and we don't know it. So then from the previous one, then we can conclude. If you don't know distributions, then we can conclude this thing. Then we can conclude. Suppose let's take x much percentage of the data. X much percentage of the data lies within this range. Means mu minus 2 sigma to mu plus 2 sigma. What is the actual value? What is this x? If we know the normal distribution, then you can conclude that in this range we have only 95% of the point. If we don't know the distributions, then how can we conclude how much points lie in this range? This is the first questions. Second questions. Second type of that we have arise. If we know what will be the value of this y value, what will be of data lies within this range, means mu minus, suppose it's the simple the 1695 talking about it's if it is integer value. If suppose let's take it's the integer, it's fractional value 1.52 mu plus 1.5 sigma. If it is our requirement, then how much value it's lie in this range? Can we conclude answer these questions? Suppose it may be anything, it may be any value. Suppose let's take its value may be minus k sigma to mu plus k sigma. K may be any number. K may be any number. Suppose it may be real number, any real number. It's any number. Then the question is how much point? What? How much? How much data? We have in this range, we have. Then how much data actually we have in this range? Can we give the answer from this data only for a data set only? We know the somehow we know the distributes mean and standard deviations. Okay, then can we give the answer? So this is the main and very applicable point of view. Always we cannot know What kind of distributions this data set are follows? So in such scenario, this is a real question and it's the applicable in real world scenario. As we progress through our lectures in a practical example, we can see this kind of problem that we faced. So let's see this thing. So let's think, just I'm taking that previously, if I just taking an examples, and through these examples we will try to understand the solutions of this problem, then I think it will be better for us for easily understand. So instead of discussing the theory step by step, if we discuss the theory through an example, then I think this technique will be better for our human visualizations. Okay, instead of taking the abstractions, if we play these things to an example, then we can extend these things to an abstract thing. Okay, so let's take this thing. Suppose let's take we know the salaries of the individuals people. Suppose let's take we are doing the job in the HR of a big company. Suppose let's take we are doing the job in a company. Okay, so suppose in a company we are doing a job. Suppose let's take in a company, the company name is, suppose let's take any company ABC. So in this company I have doing a job as a HR position, and now our main question, our main requirement is we know the salaries of the individuals of that company. We have actually our know, we know the things that in this company, that we know the salaries, we know the salaries of this company, individuals of individuals, we know the salaries of this company individuals. Okay, but we don't know its distributions, but we don't know here its distribution, but we don't know, but the here we don't know its distribution. Okay, sure. So in these cases, in such scenario for this, the how to solve these problems, but and here we know its mean, here we know its mean, analysis of individuals, and also we know things. For knowing things, I am taking it's the blue ink. I think it will be better. And we know its mean, that is finite. We know its standard deviations, that's first thing is non-zero, and as well it is finite. We know these three things, but only we don't know its distributions of that. But we want to know, but our requirement for this company is, but our requirement for this companies is first. So what percentage of individuals have a salary in that range? So first our requirement is what percentage of individuals have a salary in the range of suppose let's take 20k to 60k. Suppose let's take for better understanding, suppose let's take the mean that I have known for this company is, let's take this mean that I have known for this company. Suppose let's take the mean is 40k, that we know, and the standard deviations that from the data of the salary of individuals, that we know its mean and its standard deviation. Means its standard deviation, let's take it's 10k. Okay, now our first requirement, we want to know how much percentage of the individuals have a salary in this range. Okay, that's the first requirement. The second requirement for this company is that we want to know, the second requirement for this company is that we want to know that what percentage of individuals have a salary in the range of 10k to 70k, in this range. What percentage of individuals? So this is this kind of question. Just if you see this thing through, compare this thing in this formula. So these questions is this kind of things. These things are like, this range are like mu. Here mu is 40k. 40 minus 2 sigma means 20k. So these things are like mu minus 2 sigma, comma mu plus 2 sigma. Mu plus 2 sigma. This kind of range. And this range is like mu minus mu 40k 3 sigma, mu minus 3 sigma to mu plus 3 sigma, this kind of range. So it is these things are kind of 2 sigma range. These things is kind of 2 sigma range. This 3 is kind of 3 sigma range. So what could be the answer for these two requirement of our company? I am a user, I want to know, because this is a valid questions for a company. These are important questions also that we have to know as a user. Okay. So let's see step by step how to. So this is a valid kind of data analysis type. This is a valid data analysis type. Okay, that we want to find its answer. So to solve, to get this answer, that's the come into the picture. The main beautifulness of the beauty of the mathematics, the cap that's come into the pictures. That's the theorem is called the Chebyshev inequality. Chebyshev inequality. Chebyshev's inequality. The mathematical, the beautiful theorem in the in the in the concept of probability and statistics, that's the play into the role to get this kind of real world problem. Okay, let's see what is actually saying of this Chebyshev inequality. Suppose here we know what things that we know it's only mean and standard deviations. We know these two things, and we don't know about the distributions of our random variables. Here our random variables is salaries of individuals. This is our random variable. These things are actually random variable. Okay, so only we know here x. For x we don't know its distributions. And for x we know its mean only. No, we know only its mean and its standard deviations. That's fine. Okay, not is equals to 0, and as well both the things are finite. That's the thing that only we know. Okay, so let's see what are actually telling about this Chebyshev inequality. Let's see this thing. So the Chebyshev inequality that's telling us the probability that to give this question is telling us the probability of norm of x means random variable minus mu. Okay, it's greater than is equals to k sigma is less than is equals to 1 by k square. These things that's are telling about the Chebyshev inequality. Okay, so don't be confused of this mathematical term. So let's try to understand this thing through geometrically. in these lectures, the main motto of these lectures is not to discuss about the theoretical mathematics. The main motto of this lecture is to discuss the geometry in applicable point of view, where we apply these things, and what kind of problem that we have to face to give the answer of this Chebyshev inequality. Okay, so let's see these things to try to understand these things through a geometrical point of view. So suppose let's take it's our distributions. So let's take it's kind of our distributions. Don't be confused, it is why I am doing this Gaussian curve. Just we are already aware about the Gaussian curve, we already know about the Gaussian curve, so better understanding in this curve. So it could be any kind of distribution, any curve. This could not be, this may be any distributions. That's the thing that we have to remember. This is the any distribution. So first, that's already we know, it's the mean mu. It is the mean mu. Suppose let's take it's the first standard deviation sigma. Okay, it's the first standard deviation sigma. Okay, so what are actually telling about? Just try to understand the inside the thing in this probability. Just try to understand these things. What are actually these things? These things means x minus mu greater than is equals to k sigma, and x minus mu greater than is equals to minus k sigma. Means what? That implies x minus mu less than is equals to k sigma. Okay, so this implies x greater than is equals to k sigma plus mu. Just I am upright. Just I am write this thing through this way. I think then this will be better. Mu plus k sigma, and these things will be x less than is equals to mu minus k sigma. Mu minus k sigma. I think I'm doing some mistakes here. Okay. Understand. It will be minus chance. It will be less than equals to. Okay, just these signs will be less than equals to. Oh, sorry for that. This sign will be less than equals to. This sign will be less than equals to. So you don't need to repeat this thing again and again. Okay, so this thing that implies x less than is equals to mu minus k sigma. That's the so if you just taking the insight, this means x greater than is equals to mu plus k sigma. Suppose let's take this, the distance is k from here to here. This distance is k sigma. Suppose let's take this is the k sigma. This is the k sigma. This is the k sigma. Means from here to here the k unit distance that we have. From here to here that we have k unit distance. Okay, just if you just taken that, don't be confused about this kind of. Suppose let's take for better understanding. I think don't be confused. Okay, so this is the k sigma, this is the k sigma. So if our x greater than is equals to k sigma, just means in these regions, in these regions, in these regions, and if x less than is equals to mu minus k sigma, means in these regions, if the regions fall into that, so the Chebyshev inequality tells that this value will be in this range, the value will be less than is equals to 1 minus k square. Okay, actually Chebyshev inequality do not give the proper answer. It gives some hint about some answer. It gives some beautiful approximations of our answers. This means in this range, we have 1 minus k square, means at most 1 minus k square number of points in this range. So on oppositically, if you just op in another way, if you just think this thing, if you just visualize this thing in another way, so the yellow portions of this picture in this range, we know the whole regions is 1. If you just take the integrations, if you just find the area of this whole regions of this curve, this is actually 1. And in this range, the pink range is less than or equals to 1 minus k square. That means the yellow area must be is equals to greater than is equals to 1 by k square, greater than is equals to 1 by k square, must be greater than is equals to 1 minus 1 by k square. Its total regions each 1, total regions is 1, so the in this region must be greater than is equals to 1 minus 1 by k square. In this range we have. So I think you have understand. So if we just formulate this range, so the Chebyshev inequalities tell us, so in this range, so between in mu plus k sigma in mu minus k sigma to mu plus k sigma, means in this range we have at least 1 minus 1 by 1 minus k square number of data points we have. If we know its finite mean and finite non-zero standard deviations, then we can conclude this thing in this range. These things are that's telling about these things are tell about the Chebyshev inequality. These things means Chebyshev inequality tells about this thing. Okay, I think you have understand. So let's take this thing through an example. Let's that I have already taken here. So we know our mean is 40k and standard deviations is 10k, and we want to find this answer. Sure. Just first write down the formula. Just rewrite this formula in another way. These things. Therefore, the thing that the formula are actually saying that if our mu greater than is equals to mu plus k sigma and x is less than is equals to mu minus k sigma, then this value will be most 1 by 1 minus k square, and or another language, in another language, or these formulas can be written as probability of, means I am just writing this yellow area, yellow portions of this curve. Yellow portions can be written as mu minus k sigma less than x less than mu plus k sigma, it's greater than is equals to 1 minus 1 by k square. That's, I think these things are more valid, more easy to better understand. I think instead of using, most of the books are writing these things, but mostly I prefer this formula. Both the formula are same, but these formula are more usables in real world. So instead of taking this, so between this range, actually this is going to excluding this range. These formulas are telling about the excluding this range, and these formulas telling about the include this range, between this range. So I think this formula is better if you for easily understand. I think you have understand these things. Means I am just talking about this yellow portions from the using this white formula, white box formula. I am talking about these yellow areas, yellow portions. Okay, so this range are actually k sigma range. A sigma range and mu. A sigma range about mu. A sigma range about. So now let's try to get the answer. Just the requirement that I have taken for the company, as I am joining the HR for this company, and the company want to know this kind of requirement from me. So to get this answer, just we apply this formula. So here we see that our for this company, our for the salaries we have company, our mean is equals to here 40k, our standard deviations is here 10k for this company, standard deviations is 12k. So to get the answer, that first questions, that first requirement, so we want to find the range 60k, 20k to 60k, 20k to 60k. So how much value? So means here mu just 20k means what? 20k means mu minus 2 sigma. If you just take mu minus 2 sigma, means this is the 20k. Mu minus 2 sigma is 20k. And the 60k means what? 60k means mu plus 2 sigma, mu plus 2 sigma. So in the range of the mu plus 2 sigma, mu minus 2 sigma, how much point we have? Here actually in the range of mu minus 2 sigma less than x less than mu plus 2 sigma is here k is equals to what? K is equals to here 2. K is equals to 2. So these things will be 1 minus 2 square. So 1 by 1 minus 2 sigma means what? This value will be approximate equals to, just if you calculate this thing, so 20 less than x less than 60, it's approximate equals to 0.75. Just you calculate using your calculator, then you can easily get this value, 0.75. So we can conclude this in this range. So we can easily from these things, we can conclude this in this range we have how much employee we have. This in this range we have, in this range we have 75% of the employee are lying in this range. 75%. 75% money are lying in. Okay, we don't do any distribution, just only using these two data we can conclude at least, means the thing the Chebyshev includes at least this much employee are lying in this range. Now to get this answer, how much employee are lying on this range, 10k to 70k. So to get this answer, just apply the same thing, means our requirement is how much range, 10 to 70. 10k means what? If you just apply the same thing, 10k means what? 10k means mu minus 3 sigma. 3 sigma. 10k means mu is okay, 3 sigma 40 30, okay. And 70 means what? 40 plus 30. So probability of mu minus 3 sigma less than x less than mu plus 3 sigma, mu plus 3 sigma, it will be 1 minus 1 by 3 square, 1 by 3 square. So the probability of 10 to 70, this value will be at least 1 minus 3 square means how much? 1 minus 3 square means about how much? 90% is approximate equals to, means I think if you calculate it, 9 minus 1 means approximate equals to 8 by 9. This things is 8 by 9 actually, means approximate is equals to 90%. Approximate at least 90%. From these things we can easily go for this company, we will got at least. at least this amount of employee, this much employee are lie on this range. Okay, I think you have understand, you have got the answers of this of our this kind of valid data science questions. If we sample from this Chebyshev inequality, we get the answers. If we actually, if we don't know any distributions of a random variable, in on only we know the things its mean and its standard deviations. So to draw this kind of beautiful properties of our data sets, then we have to use this Chebyshev inequality. I think you have understand. The main motto of this lectures is to understand the geometry in real world applications. In the how we apply this theorem in the real world field, in the real world, in the in if you just, if you job a company, if you're just doing the job, if you're doing a work on a company, or then then how these mathematics are actually applicable on that. So I think this is motto of our lectures. I think you have understand the thing, how these things are applicable. If you're interested to prove in mathematically, I suggest you please go to the, just read the Wikipedia article. Then the thing is step by step easily they have discussed. Then you can easily understand these things, why these things. So to prove this theorem, to we need to know the one thing, the Markov inequality, that we have to know. So that's the not actual the motto of this series of lectures. So the our main motto is how we will understand and how will this thing apply in the real world. That's the main motto of our lectures. Okay, I think from this lecture you got some idea. Although if you have any problem, please revisit these lectures. And after that, only if you have any problem, then please comment below. Then I will try to give some explanations and a more easy way